This is file upload attacks and methodology, so file uploads in web application pen testing. This is a pretty technical slide deck, so if you're looking to fall asleep, you're in the right place. So this is what we'll go over, and you can read that yourself. So who am I? I'm a pen tester for Moss Adams.
Moss Adams.
Yep, web, API, mobile network pen testing. I have a bunch of letters after my name. Due to poor mental health, I have an addiction to letters after my name and shiny coins, challenge coins. Napoleon was once quoted to say that, talking about military awards, that he can get a man to fight long and hard and die for a few cents of ribbon. And that's basically how I am with challenge coins. If your course has a challenge coins to it, I'll probably take it. I used to do malware analysis for Symantec, and now I'm trying to write the malware myself. The more interesting parts about me is I do Utah Combat Robotics. That's kind of like BattleBots, but for smaller scale and cheaper. This is Haster. This is my 3-pound vertical spinner robot that won last year at our fall event. And that's me winning there. This is Dagon. This is my 1-pound plastic robot that did not win. He's supposed to be in one piece there, so he didn't win that event.
Broken.
What's broken? Everything's broken on there, I'm pretty sure. He got hit right in the center and just split him right in the half. I do competitive paintball when I get a chance to. I'm also a pretty avid board gamer. That's my board game room right now with Zombicide on it. I also do like miniature war games, things like that. That's Drop Zone Commander. So file uploads. We're going to talk about any time you upload a file to a web app. So this could be uploading a profile picture to your account, uploading data, if you're importing data with like a CSV file or anything like that. You'll find a lot of these functionalities in admin sections of the application. If you're doing pen testing and you get like the admin credentials and the normal user credentials, you'll definitely want to check the admin credentials and see what type of admin functionalities have some type of file upload. The reason why this is interesting, the reason why I like them so much is because it doesn't get as much scrutiny on web applications as other stuff. So if you have an input field and you can put something in there, wow, they're having more fun in that other room than we are. If you can put something in there, then that gets a lot of scrutiny. That's user input, and so they like to filter that and make sure you can't do anything in there. But when there's file uploads, it doesn't get nearly as much scrutiny because it's just a file, right? But essentially, when you're uploading a file to a web app, you're really doing some type of code execution. It's taking that file and it's rendering it. It's executing it on the server in some way. And so that is important. Like if you had an input thing that was saying like execute an OS command on a web app, you would put a lot of scrutiny into that section of the web app. So file uploads are the same thing, and we shouldn't ignore them. So where this talk kind of came from basically is I wrote the methodology for our pen test team for file uploads. So this is kind of like the checklist that we go through when our pen test team does a web app pen test and finds file uploads on a web app. And so I made it, and then they basically said, well, you might as well do a talk on it because you've done enough work. And then I got pressured into doing it by this guy, my boss. But here I am now, so you're going to hear about file uploads. So this is the checklist we'll go through, and we'll go through each step and kind of what we look for. So the first thing I tell a lot of our pen testers to always do is to find what is normal on a web app. And this is the same for any type of pen test. If it's network, web, mobile, you need to find and understand how the app is supposed to work normally. A lot of the times we don't quote unquote break stuff. The best vulnerabilities that you find are the ones that are just really undocumented features in a web app that the developers didn't really intend for you to do. So yeah, first we need to figure out how this upload functionality works. What kind of files can we upload? What do they do to those files? Where are they stored? Are they stored directly to where I can access it? Is it stored somewhere in the back end of an app where only a web ad or web app admin would have access to it? And that's becomes important functionality for the rest of the test to understand those things, especially where that file is located. This is probably the biggest thing a developer can do to protect their web app is not let that file be directly accessible to somebody like me. One of the tools that I like to use for this is this Burp file fuzzer. It's not really on the Burp App Store. It's just this kind of one-off tool that this guy designed. But I really feel like it's probably the best tool for doing this, just finding the real basics of how this file output works and what types of files it accepts. So if you have a file upload form in Burp and you send it to Intruder, you can do a pitchfork attack and you can select the file name, the content type, and the actual file itself, and then use the extensions for the type of payloads. And then you can see here you can generate random files, random file names, random meme types. And then basically you just send it through pitchfork mode and it will just go and try to upload as many files as it possibly can. So hopefully you can see that, but like payload.png, payload.exe, payload.jpg, it will try every single one of these and you can just see quickly if you get 200s or if you get 403s or 404s or whatever it is, it errors out and says, I don't accept those type things. So that's the best way that I've found to kind of quickly evaluate what is normal in the web app and what's it going to accept. Next step that we do is we check for server-side antivirus. This is kind of a mixed bag for customers. They can kind of get upset about this sometimes. But basically what we'll do is we'll upload the ICAR test file that all AVs should trigger on. Or we'll upload like something like a interpreter payload that's just straight up interpreter, no encoding, no encryption, nothing like that. So AVs should trigger on that. And then we want to see what does it do. Most of the time, most of the web apps we test, they do not have any type of AV detection, especially if the application is purposely for like file uploading and sharing of files and stuff like that, because they'll push back on us and say, well, we have to allow file uploads. But you can see why this will be bad later on. So we call this a medium severity if they allow that. But also if they do have some type of AV detection and it blocks it or deletes it later, it's important at this step to document that and figure out how that's working, because we'll go back to that later in kind of defense evasion stuff of how that process works. So next is file name injection. So this is one of my favorites because this is something we find all the time. So when you input or you upload a file, the actual file name is basically user input as well. So that is vulnerable or can be vulnerable to just as many other things as like a form on a website. So you can have cross-site scripting, you can have SQL injection, command injection, all these things can show up by just the file name. So not the actual file itself, but just the file name. So this is one that we did recently. So the file name is just right there. A few quotes, image source, alert, Moss Adams. You know, just your typical cross-site scripting. And so I upload that as the file name. And then if you see at the very bottom, you can see it there. It gets directly reflected in the application. It's doing uploading, ... and you can see my image there that's airing out. And then pop, you get cross-site scripting. Another one, so this is another different app. This one I'm looking for the local storage in the browser. And so it reflects it here, but it's actually gets reflected in a different part of the application. And this is a theme we'll go back to often is web app testing is really easy when something happens immediately. If I put an input and it comes back right back to me immediately, then that's easy. Burp can find those vulnerabilities pretty easy. The harder vulnerabilities is when something isn't directly reflected to you, but it's reflected in a different part of the application or maybe in the admin sections of the application. So this was a whole different part of the application. I upload a file and I go to this different part of the page and it processes my file and then pop, I get my cross-site scripting and my JWT token is right there, you can see. Input. uploading data. So a lot of apps will have like some type of functionality of input data, and you'll take a CSV. CSVs, Excel documents, they can all take JavaScript. And then those applications will take that data and they'll render it often. But again, they don't get as much scrutiny as like your typical form field in a web app. So if you're uploading Excel data, CSV data, throw some HTML in there, see what happens. Throw some just basic HTML, upload it, see if it gets processed, and you can see these fields 4, 5, and 6. They're rendering it in the bold, whatever the P tag is in HTML. It's rendering the HTML, so you can easily do cross-site scripting there, some other types of JavaScript attacks. Command injection. So this we look for when we can tell that it's going to accept a file and then process it in some way. It's going to throw it in a database, it's going to zip it up, or it's going to do something else interesting to it. Those are typically going to be operating system commands on the back end. So you can throw delimiters in there, like the semicolon there, and then give it an OS command. So you see right there, I'm just doing an ID thing right there. So that's the name of the file. I upload it to the app, and it executes the command. So it executes whatever the web app intended it to be doing, and then it stops and then does my ID command. These will often be blind, so they're not going to directly reflect right back to you, but that's where you can start to use Burp Collaborator, do some collaborator payloads, see if you get callbacks, command injection by just the file name. Next, paths, sorry. So when you upload a file name, a lot of the times what the web application is actually doing is it's accepting the path as just the root of where it's at. So what you want to do is put in different paths, different types of paths, absolute paths, relative paths, and see if it accepts that as well. If it accepts that, then we can do a lot more interesting stuff later on, and we'll get to that in the next few sections. But you can do some really cool stuff with that. 10 points for anybody who gets the reference to Superb Al, but we'll go on. And then server-side request forgery. This one's very common, especially if you'll get web apps that will say like upload a file and you can give it a URL where you can upload something. Those are just ripe for server-side request forgery stuff. You can try to change the file to file equals or URL equals, see if that still works. And again, these will mostly be blind, but Burp Collaborator, you can get them server-side request forgery, and you can do some pretty interesting stuff there. So that's file names. File names can do some really good stuff. Next, client-side scripts. So a lot of files that are allowed to be uploaded to apps, you can put JavaScript into them, and that is pretty awesome. Biggest offender here is SVGs. You can fit a lot of stuff into an SVG. So SVG will accept JavaScript, it will accept XML content, so you can actually throw that into the content of the file, upload it, and most web servers will just execute it. So this is an example right here of some JavaScript. If you can see there at the bottom, I just inserted that script down there, just script alert Moss Adams. Something like that would mostly render in a web app. This is perfect for your profile pictures. If you're on an application, accepts, change your profile picture, put in an SVG in there, see if it renders it. Those could be awesome. So here's an example right here. We'll see how well you can read that. But this was a preview portion of a web app where I upload a file. And again, it doesn't directly reflect me. This was a different part of the app that I had to go to and search. And it was rendering the SVG, and the SVG had JavaScript in it. And then pop, there goes my cross-site scripting. So yeah, SVGs, JavaScript, also XML. So here's some examples of XML you can easily do. Just your basic XXE attacks. You can read files on the OS. You can read directories. You can read resources. So you could read the source code for an index page or something like that with the PHP filters. Anything like that would be really interesting stuff that you could do in an SVG file. And most of the time they'll execute. Open redirects. Those can also be found there in SVGs. Pretty much anything you can do in JavaScript in a normal web app, you can do in SVG. So it opens up this huge attack vector, this huge attack surface once a web app accepts SVGs. And then PDFs are basically the same thing. Almost everyone accepts PDFs inside a web app. PDFs accept JavaScript. They accept a lot of these other scripting languages. They're harder to do a little bit, so there's a couple tools here where you can, a couple scripts that will generate these PDFs for you. And again, like most of this other stuff, it's probably going to be blind, but still, it's a way that you can get code execution on a web server, and so it's definitely not something you should ignore. Remote code execution. So this is the Moby Dick. This is what everyone wants when they do file upload stuff. If you've done any type of web app pen testing course or something like that, they'll always have something like this for remote code execution. These are harder to find just because of the severity of it, and so these get caught pretty quickly and try to be fixed. But this is, the juiciest vulnerabilities that we can find. So the biggest thing to getting remote code execution working is to figure out where this file is being uploaded. So if I uploaded a file in a web app, can I figure out where this application is storing that file? And then can I hit that again? And that's going to be the two biggest things that your developers should look at to protecting, so that person like me can't see it. Make sure that I can't hit that directory myself, and then just make sure I'm not revealing that to the end user. There's no reason the end user needs to know exactly where that file is living. So there's a few ways we can try to figure that out. A lot of the times, especially for APIs, they'll just flat out tell you. You upload a file and it will just say, like, here's exactly where it lives on the web server. Right-clicking on an image and just say View Image. It will open it up in a new tab, and a lot of times that's exactly where it lives. It's just right there, and you just hit it directly. Source code, if you have it, if you're doing a white box test, that's great too. A lot of times we don't have that. But then look for error messages. Error messages often will just reveal to you where a file's located, get it to error out somehow, put in an overly long name, put in characters that shouldn't be there, a duplicate file name, so two files, upload a file with the same name, see what happens. And then once it errors out, it will usually tell you something of like, well, I can't do that because this file right here in this web server already exists. Great. And then after that, this is going to be all the different ways we can do remote code execution. So don't forget your methods. So your methods is kind of a boring task in web app pen testing, what methods are accepted on each endpoint. But if they accept put requests, or if they're using put requests to upload the file, often you can just ignore the whole functionality and the process it has for web app uploads, and you can just do a put request directly to the web server and it will accept it. So you're bypassing all the defenses, you're bypassing all the file extensions that it likes and doesn't like. It would just put directly to the web server. Wonderful. Path traversal. So this is where we were talking about doing those paths in the file uploads. If it accepts paths, then it can start to do a lot of interesting stuff with that. So I can put in myfile.php. If it accepts that, then we can start to override files on the web server. So there's .htaccess on Apache. We can upload our own .htaccess file, and we can overwrite that configuration on the Apache web server, and then we can put in whatever configuration we want in there. .ASP.NET, it's going to be web.config. if there's SSH on the box, or if they're running SSH on the box, probably on the back end, not something you can see, but there's going to be authorized keys in there. You could overwrite the authorized keys with my own authorized key. And then suddenly there's a whole nother vector that's going to be interesting for you to go after. Example here, so with that .ht access, like .ht access will configure the certain types of extensions that are executable. So maybe you're trying to get PHP files to execute, but you can't get them to execute because it's not allowing you to execute them. If I upload that .ht access file, I can add this line, add type, and then I can just make up my own extension, .leet, because that's what we do. And then .leet will now execute once I upload that as HT access. And so that's kind of an OPSEC way to do some of these file upload things. Instead of just allowing all extensions to be accepted, I can now do this completely custom extension that no one else is going to stumble upon. And then I can do my attacks from there. Server-side includes. Those can be done as well. Put those into your file payloads. See what happens when you upload them. See if they can include those files into the web app. All possible. So some of these are other ones that I put. These ones are mostly patched, but they do come around every once in a while. They can be quite interesting. If you ever heard of the zip slip kind of attack, basically this is where you can tell a zip file for when it uncompresses itself. You can give it a specific directory where to decompress itself. So I can say, when I uncompress, store this file on var www.html, so right on the web directory root. And then that's a file I can now hit directly instead of getting blocked by all the other defenses on the web app. Symlinks, imager processor vulnerabilities. So a lot of times on a web app, you upload a file, you upload a profile picture, and then it will render it somehow. It will try to compress it. It will say it's too big. It will crop it or something like that. There is a web library in the back end that's doing that to modify those images. Those have vulnerabilities. And if those aren't patched, then you can easily give it a specific file that will exploit that and give you some type of code execution. So again, those are often patched, but they do come out every once in a while. I think one of these come out like 6 months ago or something like that. 6 months is not a terribly long time for something to be patched, especially an image library thing that sysadmin's going to think that's not a big deal. So it's always good to check those, especially if you can see that they're processing your profile picture in some way. And then combining vulnerabilities. So file upload becomes a springboard for a lot of other attacks. So if I can get cross-site scripting on your website, then I can start to do a lot more interesting stuff with the application. I can pivot that with cross-site request forgery. I can start making requests, authenticated requests as the user. So I can hit admin functionality. I can create my own account or create my own user, things like that. So file uploads, if I have that cross-site scripting in like an SVG file or the file name like we showed, then that becomes just a springboard for lots of other attacks. One of the favorite ones is LFI. So we talked about file uploads and trying to get remote code execution. That's mostly done by uploading some type of web shell. So we get a web shell, we upload it, then we hit it, and we can do code execution. But if I can't hit that file directly, or if it's not going to render it like I want it to, so I upload a PHP web shell, but it doesn't render it, if I can get a local file include vulnerability, then I can do a lot of stuff combining those two. So this .profiles images shell.gif, I can't hit that file directly, but with an LFI, I can tell the web app through the LFI vulnerability to now go hit that web shell. And since it's not the user hitting the web shell, it's actually the web app itself hitting the web shell, it typically goes straight through because it's trusted. And so I'm kind of combining those from the LFI hitting the web shell and then I'm doing my command equals ID, and that gets me my OS command execution. So yeah, file uploads can be a great opportunity to just be a springboard to a lot of other attacks. Then let's talk about defense evasion, because we have to talk about defense evasion because everything has defenses. So this is a few of the things that we'll go through. There's a lot of them, and this is just going to be a big info dump about all sorts of the stuff that you can do with it, but that's what this talk is, big info dump. So first one is race conditions. So this goes back to that server-side antivirus. We will see race conditions a lot when there is a back-end antivirus blocking my files. So I upload a file, it gets on there, and then I get some type of alert, like this file isn't accepted, or usually won't tell you like it's an AV alert or something bad like that. It will just give you a generic, like, these types of files aren't accepted. You can't upload interpreter shells to my web server. But understanding that process of what was normal at the very beginning we talked about, like how the app works, you can find race conditions. So like this one that I showed earlier was actually a race condition. There was 2 web servers here. There was the normal web server, was a Windows web server. But then when you uploaded the file, it also duplicated it onto this preview subdomain. And the preview subdomain was actually Linux, which screwed me up for a long time because I couldn't understand why my things weren't running. But when the AV caught it, it immediately deleted it on the Windows side, but it took about 5 to 10 minutes for it to delete it on the Linux side. And so given the structure of the file name and the location of where it was at, I could figure out where that file was on the Linux server, and I had about 5 or 10 minutes to hit that file before it actually got deleted. So another problem that comes with that back-end server-side antivirus. That's where we typically see a lot of these race conditions. Content type manipulation. So this is all going to be, I should probably preface this, but so how do we get past when it doesn't want to accept a file we want to give it? So we're uploading files to a profile picture. We want to upload some type of web shell. A web shell is going to need to be like a PHP file, something that will execute code, not just an image. But it doesn't allow us to accept PHP files. So how do we get past that? That's where most of these are going to come in now. So content type manipulation. If you look at the request over here on the right, content type, this is a file upload form. It's saying image PNG. The file name is black.png, and you can see the file there is a PNG file. You can just start screwing with that content types. A lot of these web apps, especially if they're doing it custom, they're not using a well-known library to do the file uploads. They won't parse these things correctly, or they won't be checking them correctly. So you can just start manipulating that. Put it into an intruder and change all the different content types and see what happens. Put in a different content type with a disallowed extension, disallowed content type with an allowed extension, see which ones get passed. You can remove the content type altogether, and then sometimes it just kind of errors out and accepts it. So that's, I'm fine with that, okay. Try to do 2 different file names. See if it helps. See if it will accept both of them. That can often work too. Content type manipulation. So client-side bypasses. We see this more often than you think, that it won't accept PHP files, but it's all on the client side. It's all JavaScript that's saying you can't do this. Well, that's pretty bad. We can just manipulate that. We can intercept that with burp and then just change it on the fly and send it right off. We have a separate finding for this in our reports that we give out as Moss Adams of restrictions not enforced on server side. All your restrictions should be enforced on the server side. So yeah, intercept it with burp, change it to whatever you want, let it go off. Magic bytes. So they're looking at the content type, they're looking at the extension properly. Sometimes what they'll also do is they'll look at the content, the actual file itself, and they'll look for magic bytes. So the first few bytes of a file. So an executable is like mz ... A GIF is a GIF 89A is the first few bytes. So when they're checking to make sure that this is a valid file, most of the time what they're doing is they're not going to read the entire file. They're just checking the first few bytes. And they see that GIF 89 and they say, yep, you're actually GIF. And they just let you go right by. So you can see where we're going here. That's pretty easy just to bypass. So right here, I'm uploading my PHP backdoor. I'm doing a double extension here, which we'll see later. And then I'm just putting in that GIF 87A. The web application's reading that GIF 87A and says, yep, you are completely legitimately a GIF. And I accept that as a profile picture. And then you can see that it's just a very simple PHP code that I'm uploading. So you hit it when you can hit it, and then you see that GIF 87A is rendering there, but whatever. The rest of it is PHP code, and I'm now executing on your web app. So yeah, other extensions you can do, other magic bytes, GIFs, PNGs, JPEGs. But just all you have to do is just put that in the very front, put it through burp repeater, and put it at the very beginning of a file. It will probably accept it and say, yep, that's a PNG file. I'll accept that. And then you can just Google and find whatever file magic bytes you want for others. Insufficient blacklisting. So when they have certain files that they don't want you to run, there's actually a lot more of these files that you don't know of that will actually execute. So .php, is a typical PHP file. That's where we can do remote code execution. But PHP2, PHP3, those are also PHP extensions, and they execute just the same as a PHP file. And so if they're blacklisting PHP files, they need to also blacklist all the PHP files that run as PHP. And there's actually more than just this. This is kind of a short list. So you basically just want to create a list, send it to Intruder, and just fire it off and see will it accept any of these other types of PHP files, or if you're Windows, ASPX files, anything like that. SecList has a pretty good list that you can just use in your Intruder attack to see which ones will find, which ones will be let through. So we call that insufficient blacklisting. And then the rest of what this comes down to is just trying to obfuscate the file extensions in some way so that you can confuse the web app to actually accept a file extension that you don't want it to accept. So we saw this a little bit before, but doing double extensions, sometimes it will read the file name, and then once it gets past the dot and the extension, it will just stop and say shell.jpg, and it just finishes and says, yep, JPEG. Where it was actually jpeg.php, and it's actually going to execute as a PHP, but it didn't see that. So double extensions, putting a slash at the end of it could screw up the parsing. Sometimes if you give it a really long file name, it will just error out and just accept it. And so it won't see that it's an executable extension. Don't put an extension at all. Don't put a file name in at all. See what happens. Windows dots, this is specifically for Windows, but if they're blacklisting like .aspx files and do a .aspx ... the blacklist will look at that and say, well, we're blacklisting .aspx. .aspx is not equals to .aspx ... So it will let it through because that's not the one we're blacklisting. But then Windows always just cuts off those dots. And so it actually goes through as a .aspx and then executes, and everything's good. Then character injection. So this is just a way to kind of screw up the parsing as well. Put in delimiters, put in a new line, put in character encodings, spaces. You can see if it will just parse that and forget the extension and just keep on going through. And then basically just mix and match this. This is a guy that I actually follow him on LinkedIn, but he posts stuff like this all the time, just a bunch of different lists that you can use to do character injection. He does all sorts of web app stuff, web app and API. But yeah, like you just mix and match all these different kind of defense evasions, and eventually you'll probably find something that will kind of let you through and accept it. And then, yeah, this is a good little image you can find on the web. Just Google it real quick. But this is kind of a mind map of what you do with file uploads. So once you find a file upload, different mind map of different directions you can go with it and see what you can do. Okay, so that was a lot. My mouth is dry. But we'll talk about a little bit of automation. So have you heard of polyglot file files? People will do that with a lot of injection attacks. Like it's just a file with quotes and double quotes and slashes and all sorts of characters, HTML characters, and it tests for all sorts of different input injection attacks. You can do the same with file uploads. There's one there on the link, file upload polyglot, that you can just upload to anything when you're feeling lazy. And it will give you some indication if it's going to execute JavaScript inside or if the file name has a vulnerability there. Upload those. The next one we're going to do is probably my favorite one. This is going to be from Burp Upload Scanner is what we're going to do. And we're going to show you against this Clairline app. This was, I think it's a French app, but it was a learning platform application. And so it has a CVE from last year, so this is pretty recent. This stuff happens, and the actual CVE was for remote code execution with some defense evasion on the profile picture. So the magic bytes, and using a double extension, you can upload an executable file, and you can get remote execution on the file on the server. So if you see there, that's the user profile picture right there. I need to find out where this is being dropped. I look, open image, a new tab. It gives me a directory and everything, and that's exactly where my file is being uploaded, just my plain black file. I don't know why it does that like A's forever, but then it gives it a custom name for the file, and then it executes it. And so all you have to do is put in a backdoor, PHP backdoor web shell, and then you hit that directly, cmd equals, and put your command in there, and then I got code execution. And you can see that GIF 8 right there. That's doing the magic bytes at the very beginning, saying, hey, I'm actually GIF, and it's reading those first few magic bytes and says, yep, you're a GIF, and he accepts it. So what I wanted to do is take this vulnerability and show you how Burp Upload Scanner works and what it can do with that. Burp Upload Scanner can be a really interesting tool. It works the best when it can directly read where the file exists. So like we talked about, when you upload a file, sometimes it's not directly shown to you, or it's only shown to admins or someone else. It's not directly in front of you. If Burp Upload Scanner can't see it directly, then it's going to struggle with this a little bit. You can still get some out of it, but you can still do some pretty cool things. So it's an extension in Burp. I think it's a Pro extension. You have to have Burp Pro. But basically, it will run a lot of these attacks that we've all talked about here. So if you're looking at the modules that you're running, it's going to upload SVGs and PDFs and XMLs and CSVs. It's going to run attacks for those image library vulnerabilities. It's going to test for those ones. And you can disconnect some of these that you don't want to run. It also does some fuzzing and some DOS stuff. Those are those three that are unchecked right there. You might want to check that carefully, because with file uploads, and especially if the application is doing some back-end processing, OS processing, you can easily kill the web app. So I would almost always turn off those DOS ones and stuff, because you can kill the app just with this tool itself, let alone telling the tool to say, hey, let's test for some DOS vulnerabilities. So yeah, we'll send it over. This is what it will look like. This is the one on the Caroline's app. So it's a post request. Here's my form. You can see the file name there, the content type, and then that's the test file we're using, just that black PNG file. And then the niftiest feature of this upload scanner is it has this read downloader feature. because most of these vulnerabilities we can't exploit unless we can hit the uploaded file again. And so what we can do is we can configure burp upload scanner to find where that file just got uploaded, and then he'll hit it again, and then he'll try to see if those vulnerabilities exist. So he'll upload probably like 300 or 400 files, and then he'll hit those files again, and then he'll send it here to your dashboard of are they successful or what happened. So to do that, this is the response from a typical file upload. This is the API coming back saying you uploaded this black.png, and then like I said, the APIs usually often tell you exactly where it's being stored. And so you can see then the URL right there, /data/ and the file name that it generated. So with this read downloader, we can configure that to read that response and parse it. So if you can see there kind of carefully, we're saying after URL, start taking all of that up until where it says meme type or something like that, and it will just take that directory and that file path. We're taking away the backslashes, we're adding a slash to it, and we're tacking that onto the root domain. And then there's some test requests that you can send. So it will send that request, and you can see if it's actually working or not, if it's actually hitting that PNG file properly. And then you just manipulate that until you can get burp upload scanner to properly parse that request and send that request off. But once you've done that, you just hit go, and he just crawls through that and just sends almost, I think it's like 200 or 300 files that he'll send off, and he'll send it off pretty quickly. We often do this towards the end of a pen test because of how intensive this one can be. And we're doing some OS stuff, and so we don't want to break the app at the beginning of an engagement. If you're going to break something, break it towards the end. So we do this towards the end. But it will send it off, and then you can see up there, like it will show you this one came through, this is the file it sent, it got a 200, or it got a 422, it didn't like it. And you can read all the requests and all the responses and see what happened. And then it will send it to your dashboard of what was successful and what was not. So this original one, the CVE was for PHP code injection, PHP code execution, remote code execution. And so he saw that there, the PHP code injection, and he did it several different ways, so you're pretty convinced it's code injection. But he also found this cross-site scripting stored, which was kind of interesting because that wasn't in the CVE. So we look at that one in burp, and if you can see it there at the top, he did it through an SVG. So he's rendering an SVG. That SVG has a little bit of JavaScript, and we're doing cross-site scripting there. It's just popping up a form in an alert box. So that's cross-site scripting now in that Caroline thing that we can add to that CVE. Yeah, so that's file uploads. File uploads is basically code execution. And if you had anywhere else in a web app that was executing code, you would take that pretty seriously. But for some reason, in my experience, when it's file uploads, they just don't get enough scrutiny from the developers and the security analysts. And so they can be really important. They can do some really interesting exploits like cross-site scripting, server-side request forgery, and then those can be pretty big springboards to lots of other attacks throughout the application. And I think we're pretty good, so we'll just do questions at that point.
Do you have a collection of common abused file extensions?
Do I have a collection of common abused file extensions? I mean, most of the time it's what people use. So like PHP is most of what I see. PHP and Windows, ASPX stuff. That's most of what we end up using. And then the CSV stuff. If you can upload a lot of stuff, a lot of the applications will allow you to import data, you know. So as CSVs, they'll pretty much just take a CSV no matter what you do to it. If I have JavaScript in it, if I have macros or anything like that, it will just accept it. And so those are pretty abused often. Okay, well, thanks for staying awake. That's file uploads.